Hi everyone, I am Ronak Yadav, and if you have been following along with our previous videos, you know how important it to handle the data before jumping straight into machine learning model. But how do we go from raw data to something that a model can work with? So let's understand data preparation phase to model the data. The data preparation phase is a critical step in the data science workflow. Ensure the quality and relevance of data before feeding into a model. Here's a breakdown of the main task involved. First is the data collection. Gather the data. Collect data from various sources such as database, API, web scraping, or other data repositories. Then data exploration. Visual analysis. Use a visualization like histogram, scatter plots to understand the distribution and relationship. And third one is the data cleaning. Handle missing values, impute, remove or flag missing data based on its impact. Remove duplicates, eliminate duplicate records to avoid bias. Uh, Correct errors and outliers, identify and address anomalies or extreme values. Then data transformation, feature engineering create new features that capture more information or improve the model's performance. Scaling and normalization, apply techniques like min-max scaling or z-score normalization for numeric features. Data splittings, train test split, divide the data into training and testing set. Example 80 to 20 or 70 to 30 splits. Cross validation, consider k-fold cross validation for about robust model evaluation. The seventh one is the feature selection, that is feature importance. Use statistical methods, correlation analysis, or model based features important metrics to select the most relevant features. And the eighth one is data visualization. Data consistency, validate the data's consistency across column and check for logical coherence. Data quality checks ensure the quality of data by re-evaluating each transformation step and detect the issues. Now, let's understand the partition data by using the Python. Partition data or splitting it into a training and testing set or validation set is a key step in data analysis and machine learning. You can perform data partitioning in both R and Python. Below are methods for both language. In Python, you can train set split from sklearn model selection modules. Here you need to create a data frame, then split the data frame. So let's understand this by an example. So I have created a code. I have already write a code. So in this example, we have created a data frame and then we features it. Now on the x-axis we drop the target, on the y-axis, sorry, on the x-axis we target the features, and on the y-axis we plot the target. The data frame contains feature 1, feature 2 and the target. Then we split the data into 80% training and 20% testing slots. Then on the basis of this data set, when we run the code, we will get the output like this. Training features, feature 1 and feature 2, we will get this output, and for testing features, feature 1, feature 2 are this, and for training target, we will get these output. Name, like the name is target and the data type is in 64. Okay, so this is the example of partitioning the data by using Python. Now let's see another example. Build random forest by using Python or R, but in this example we will going to build a random forest by using Python. So to build a random forest, we need to import certain libraries like pandas, imlearn, sklearn, and there we create a imbalanced data sheet which contain data frames like feature 1, feature 2 and the target sheet. Then we plot these values on the x-axis and y-axis, and then split the data into training set, like training set and the testing set, where the ratio is 80% and the 20%. Then apply random oversampling on the training data set. After the check the classes distribution after oversampling. Here xtrain.value counts and y resample.value count functions are used to class distribution over the before the oversampling. Now if we execute this code, we will get the output like this. Class distribution before oversampling is the target 1 and the name count d type is 16. Class distribution after oversampling, the output will be this. Now let's move to the other example, other topic, that is build cart decision tree using Python or R. For this, I have created example. So let's see. Here, install the necessary required libraries like pandas, sklearn, and matplotlib to plot the graph and build a sample data. So here we are using iris dataset. To iris dataset had features like target and the features like data, and the target is target, which is species. Split the data into training set and the testing set. Then build the classification tree using the decision tree classifier. Then print the tree. So the tree would be like this. If you run the code, you will get the tree like this. This is the decision tree, which is built by regression tree using the decision tree. Okay. Here the visualization of the tree. Here it is the output of this code. So as you can see the output of the code. Here is another example in which we are building a random forest model for classifier. So again we load the arrays data set, build a random forest. We are building a random forest. For this we have taken the data of the arrays data set, then split the data into training and testing set, then build a random forest classifier by using random forest classifier function, then print the model accuracy on the data set. Then we predicted the model by using the predict function, evaluate the performance, and then we build the random forest model for regression also. So for this we load a California housing data set, and then split the data. Then again build the random forest regressor. Then print the model accuracy and predict using the model. Then we get the output. The output is like the accuracy is 100%. Classification report. Precision is, this is the precision record. This is recall record. This is F1 score record, and this is support. So in this video, I taught you about the data preparation phases to model the data. Thank you.